Okay, so what accounts for the kind of hallucinogenic effects of these drugs? Like, how do these drugs produce these rather dramatic, sort of perceptual and also cognitive distortions, right? Well, it turns out that chemically, these drugs actually either resemble serotonin, okay, or they resemble norepinephrine. They look a lot like monoamines, okay? So they act at monoamine receptors in the brain, and it turns out that different, hallucinogenic drugs will act at a different set, of monoamine receptors, okay? But they share a common locus of activation. It turns out that LSD, mescaline, psilocin, DMT, all these drugs actually act as agonists at 5-HT2 receptors. Okay, these are serotonin receptors. There's a specific one that they all act at. They're agonists at 5-HT2A receptors. So they all act at 5-HT2A receptors. And it turns out that the degree to which they act as an agonist, how well they bind, how well they stimulate that particular receptor, is correlated with how much of an hallucinogenic effect they generate. Okay, so but let's go one step further. How does drug action at these 5-HT2 receptors, particularly 5-HT2A, provoke hallucinations and cognitive distortions, right? And there are two leading hypotheses. Okay? The first is that when you take these hallucinogenic drugs, what you notice is that the locus ceruleus, right, which is the brainstem nucleus, that's the source of norepinephrine release in the brain, right, tends to fire much more dramatically to sensory stimuli. Okay? Now think about how this nucleus acts typically. So if something novel or unusual or strange occurs, right, something that would provoke release of norepinephrine from the locus ceruleus, right? Let's say you enhanced the release of norepinephrine, and at the same time, these drugs tend to reduce the typical level of norepinephrine release from the locus ceruleus. So they quiet down the locus ceruleus and release norepinephrine until you see something or experience some stimulus. So they increase the response, basically, of the locus ceruleus and release of norepinephrine to stimuli while cutting down the background. So this is one proposal, is that by this mechanism, they sort of heighten, the visual, the auditory, the sensory aspects, right, of stimuli that you're looking at. And a lot of folks who take these drugs and wrote about them talked about, the stunning visual effects, they were sort of drawn to and focused on, like, let's say the tubularity of a chair leg and things that would not normally provoke, powerful sort of attention and, kind of examination, really captured their attention and had this sort of heightened kind of visual kind of influence and effect, right? The other kind of idea is that hallucinogenic drugs actually act at these 5-HT2 receptors, right, that are located in the thalamus, okay? They're also located in the basal ganglia. They're located in the prefrontal cortex. They're located in a lot of networks in the brain that are important for both sensory, processing, like in the thalamus. Any kind of sensory information gets processed in the thalamus before, arriving in cortex, and also in networks and regions that are associated with, cognitive function, with kind of higher cognitive abilities. So perhaps these drugs are disrupting the usual gating of sensation and, the operation of networks that are involved in cognition.